Hello everyone, myself Sabina Devi, Assistant Professor, Department of Physics, SNS College of Technology. So in previous video, I explained about different types of elastic modulus, right? So in this video, I am going to explain about stress strain diagram. Okay. So factor of safety. So what is the factor of safety here is to avoid permanent elastic limit with a working stress. Okay. So to avoid permanent elastic limit while giving more amount of stress to the body, it will lose its elasticity, so it becomes a plastic material, right? So we have to avoid the permanent elastic limit with a working stress, right? So the factor of safety deformation is due to the maximum stress above which a material loses. The engineering tools are to be used within the factor of safety. So these are all the factors safety. Okay. So the factor of safety is equivalent to breaking stress by working stress. So breaking stress is nothing but the maximum amount of stress that can be applied to the body. So after that it will become the plastic body. Okay. So the working stress is the normal stress, right? So these are all the factor of safety. So more amount of stress is applied to the body, the elastic body will transform into plastic body, right? So here in this video I am going to explain about stress strain diagram. Okay. So we know that in Hooke's law he explained about, so while increasing stress to the body, the strain also gets increases, right? So it is the plot of drawing variation of stress versus strain. Okay. So variation of stress versus strain. So stress strain diagram is the graph plotted between the stress to the strain. The stress strain curve for different material is different, right? So stress and strain, the curve is different for different material. It may vary due to the temperature and the loading condition of the material, right? Okay. Okay, look at this diagram. So this is the stress and strain diagram, right? So now the graph is plotted between the stress to the strain. In x-axis, the strain will be plotted, and in y-axis, the stress will be in plotted. Okay. So initially, due to the Hooke's law, so while applying, so stress will be increases, strain also will increases up to the point A. Okay. So up to point A. So while increasing stress, strain also increases. After removal of stress, it comes to its original condition, right? So original position. So this is called as the proportional limit or elastic limit. So before this is the called a elastic region. So while increasing stress, strain also increases gradually. So it obeys Hooke's law. After that point A, so it doesn't obey Hooke's law because A is the elastic limit, right? So while increasing stress, strain also increases up to point A. So up to point A, it will obey the Hooke's law, right? So after point A, so while increasing stress, strain also increases, but not gradually. It will not obey Hooke's law. So the smaller amount of stress also will cause maximum amount of strain here. Okay. So that point is called as elastic limit or yield point. Okay. So next this is the point B is called as the elastic limit or yield point. Okay. So here smaller amount of stress also will cause the maximum amount of strain, right? So after B, so we decreasing the stress value, but here also the strain will be increases. So in point C, while decreasing stress, it will increase the strain. That called a lower yield point. After that C, it becomes a plastic region. It doesn't regain its original shape or size, right? So this is called a plastic region. After the body A, after the point A, it will obey Hooke's law, and it will comes to after the removal of stress, it will come to original shape and size, right? After that A, it will become a plastic region. It does not regain its original shape and body. Okay. So here lower yield point. So while again we increasing the stress up to D, this is the breaking stress. So after that point, it will reach the fracture point, right? So after increasing the stress, it will reach the point E. After that point E, it will break. Okay. So in this video, I explained about stress strain diagram. So here we have 5 points A, B, C, D, and E. So up to A, it obeys Hooke's law. After the removal of stress, it will regain its original shape and size, right? Okay. So after A, so a smaller amount of stress will increase will cause the maximum amount of strain, right? After that point B, while decreasing stress but also increasing strain, right? Again increasing the stress up to D, okay, it will reach the breaking stress. Okay, so after point E, it will reach the fracture point. Okay, so this is the stress strain diagram. Thank you all.